All right, guys. So today we looked at the idea of an investigation 3, just talking about factoring, factoring by grouping, and factoring by cubics. So that's kind of what I want to try to do is just kind of do a quick review over all that stuff for you. Let's look at in your notes. You guys have an example like this in which you're asked to factor 2x squared plus 10x minus 48, and in this case, we're trying to find out what the greatest common factor is. All of these are even numbers, therefore we can divide all of them by 2. So when I factor out a 2, I end up with x squared plus 5x minus 24. So now, once I factor that greatest common factor out, what I want to do is I want to try to factor out this trinomial, x squared plus 5x minus 24. So when we find that factor, we are multiplying that first coefficient, which is 1, in this case times negative 24. So we're looking for a product of negative 24, but in this case a sum of 5. So what two terms gets me a product of negative 24 and a sum of 5? That is 8 and also negative 3. So I have x squared plus 8x minus 3x minus 24. So we're going to factor by grouping. So I have an x that goes into both of those. So I get x times x plus 8. And then I have a negative 3 that goes into those. So I have negative 3x plus 8. So your factored form would be x minus 3, x plus 8, with a 2 in front of it. And this would be your factored form. 2 times x minus 3, x plus 8. This is also asking us to find out what the zeros are. The way we find the zeros is, remember, we could set the binomials equal to 0. So we could say x minus 3 equal to 0, x plus 8 equal to 0. Okay. And you guys would get x to be 3 and also x to be negative 8. So your zeros would be 3 and negative 8. So like with those first few problems, it's very similar to like the last video that I showed you guys dealing with just factoring. So I encourage you guys to look at that. What I want to do is I want to jump into like kind of the newer stuff that we did today. The newer stuff that we looked at dealt with factoring by grouping. And so if you guys look at question number 9, it's asking us to factor the following quantity by grouping. And that's what we've been doing. It's just different because I don't have to figure out like what I'm grouping together. I don't have to figure out another term. This one I have 2 terms. I have x cubed plus 2x squared, and then I have a negative 9x minus 18. So I want to look at x cubed plus 2x squared and figure out what the greatest common factor is. That is x squared. So I have x squared times x plus 2. So if I distribute x squared times x, I get x cubed. X squared times 2 gets me 2x squared. Now we're going to look at negative 9x minus 18. That is a minus 9 that goes into both of those. So I have minus 9, and then I also have x plus 2. So right now, your factored form would be x squared minus 9 times x plus 2. Okay? Now I still have something to the second power. I have x squared minus 9. This is considered to be a sum and difference pattern that I know that when I have a minus in front of a complete or a value that's a perfect square, I can rewrite this as x plus 3 and x minus 3. So where did I get the 3 from? It's from the square root of that 9, which gives me that positive 3 and that negative 3, times x plus 2. Okay? So your factored form would be f of x equals x plus 3, x minus 3, x plus 2. Now we just want to find out what those zeros are. So we're going to set x plus 3 equal to 0, x minus 3 equal to 0, and x plus 2 equal to 0. And when I do that, I get x to be negative 3, I get x to be positive 3, and I also get x to be negative 2. Those are the zeros. So you have your factored form of f of x equals x plus 3 times x minus 3 times x plus 2, and you guys get your zeros to be at negative 3, 3, and negative 2. Let's look at one more by grouping. So I got 2x to the third minus 5x squared plus 6x minus 15. If I look at these two terms, the greatest common factor is x squared. If I look at the greatest common factor between those two, it looks like it's 3. So I have x squared, and then I end up having 2x minus 5, and then plus 3, which gets me 2x minus 5 as well. So when I look at this, I end up getting x squared plus 3 times 2x minus 5. So that's what f of x equals. So I look at 2x minus 5. I can find out what that 0 is. But let's kind of look at what the graph is. So I plug the equation into my calculator. And if I look at this graph, this is what I get. Okay? If I look at it, how many times does this graph hit the x-axis? It hits it exactly once. And if I look at anywhere else, it curves just like a cubic would, and then it hits the x-axis at 5,2 over 2. So in this case, I know that this quantity, if I set x squared plus 3 equal to 0, it's not going to work out. That's not going to be a real solution. And we'll talk more about that in a future lesson about what type of solution that is. But I could set 2x minus 5 equal to 0. And you guys would get 2x to equal 5. And you guys would x to be 5 over 2. So this is your factored form. Okay. And I got a solution at 5,2. I encourage you guys, try the next couple. In the next video dealing with cubics, I will go over that and then kind of deal with cubics.